So in this lecture, we'll first talk about product term and min term. Then we'll talk about sum term, max term. Then finally about Karnoff map, or simply K-map. So a product term is a term or an expression where there is only the product operations or the AND operations. So only AND operations. So for example, if I say A, B, C prime, that's a product term. So if I say A plus B, C prime, that's not a product term, because there is the OR operation. If I say A prime, B, C, D, E prime, then it's a product term. On the other side, A plus B prime is not a product term, because there is the OR operation here. So now, so we want to learn. So what is a min term? So min term is a particular form of product term, or a special version of product term. So if there is a digital system, then we have a set of variables for the system. So in a product term, if all the variables exist, then it is called a min term. So min term is a product term where all variables exist. So for example, so we have two variables, A, B, a system of two variables. In that system, we have only the variables A and B. So now we say A is a product term, but it's not a min term. So A, B prime is a product term. It's also a min term, because in this term both A and B exist. Now for a three variable case, A, B, C, A, B prime is not a min term, because C doesn't exist. A prime, B, C is a min term, because all of these three variables exist. Now the question is, so in case of two variables, so how many min terms there are? So if we have two variable systems, two variables A, B, then the product terms can be A prime, B prime, A prime, B, A, B prime, A, B. This four min terms. Four min terms for a two variable case. And the first min term is denoted by using M0, then M1, lowercase m, M2, M3. Now in case of three variables, so if we have three variables and the variables are A, B, C, then we got 8 min terms total. A prime, B prime, C prime, A prime, B prime, C, A prime, B, C prime, A prime, B, C, then A, B prime, C prime, A B prime C, A B C prime, A B C. So 8 minterms. 1 2 3 4 5 6 7 8. The first minterm is M0, then M1, M2, then M3, M4, M5, M6, M7. Now the important thing is that any expression can be expressed by using only the minterms. So any expression can be expressed by using only the minterms. So for example, so we are given an expression or a function, and express this function using minterms. Express a function of 3 variables a, b, c, a plus b, c using minterms. Okay, so we are given this function a plus b, c, and we want to express this function by using minterms only. How do we do that? So there are 2 ways of doing that. Let's work with the first way. Two ways. First of 2 ways. The first way. We are given it a plus b, c. So now here in a, b and c are missing. So we can write a times b plus b prime, c plus c prime, plus in bc a is missing. So we can write a plus a prime bc. So how do we write it? We know that b plus b prime equals 1, c plus c prime equals 1. So a times 1 times 1 equals a. Then similarly, a plus a prime is 1. Then a plus a prime times bc gives us bc. So putting here, adding here a plus a prime is okay, is correct. So now we apply the distributive principle. Then we got ab plus a b prime, and we still have c plus c prime, plus a b c plus a prime b c, the distributive principle. Now again the distributive principle, a b c plus a prime, it's not a prime, but it's only a b c, then a b c prime, plus a b prime c plus a b prime c prime, plus a b c plus a prime a c. Now we need space. Also so a b c, so a b c, ABC. Do we have ABC? Okay, so 1 ABC, 2 ABC. So now ABC plus ABC is actually ABC. So now then A, B, C prime. A, B, C prime. Do we have A, B, C prime? No. Then A, B prime, C. Do we have that? No. So you got A, B, C prime, A, B prime, C, then A, B prime, C prime. Then A, B, C, we already got that. A prime, B, C plus A prime, B, C. So then we don't need that anymore. Now, so what is that ABC? This ABC is actually mean term 7, M7 plus ABC prime is M6 plus AB prime C M5 plus AB prime C prime M4 plus A prime BC M3. So we actually got M7 plus M6 plus M5 plus M4 plus M3. So this is also expressed as sum of M. So what do we have? 3, 4, 5, 6, 7. 3, 4, 5, 6, 7 in some order. 3, 4, 5, 6, 7. So this is so another way of denoting a function in terms of the mean terms. This guy and that guy means the same thing. It's actually 3, 4, 5, 6, 7. So now let's see how we can express the same function by using another way. Okay, it's now the second way. Second way is the truth table way. So now we have the function A plus BC. We want to find the truth table. So we have A, B, C. And we want to find the truth table A plus B, C. Okay, so now we have 8 combinations. 1, 2, 3, 4, 5, 6, 7, 8. 0, 0, 0, 0, 0, 1. 0, 1, 0, 0, 1, 1. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So do we have for the first one? It's 0. For the second one, it's also 0. A plus BC is also 0. Then BC 1, 1, 1, 1, 1. So it's very easy. Now we can actually express the function f a b c in terms of the mean terms m of. So why do we have the ones in 0? In the first row we don't have second row. Also the row number so row number 0, row number 1, row number 2, row number 3, row number 4, row number 5, row number 6, row number 7. So now we have 0 in the first row, 0 again, 0 again. So we have 1, we have this 1 in the third row. So now we put it 3, then 4, 5, 6, 7, 3, 4, 5, 6, 7, and this is the same thing. Okay, so now I think by using the truth table, finding or expressing an expression in mean terms is easier than by using the Boolean identities. So we now talk about sum term and a max term. So sum term only the OR operations. For example, if I say A plus BC, then it is not a sum term because it's a AND operation. A B C is a sum term. A prime B C prime is a sum term. Now A prime B C prime D plus E is not a sum term. So similarly, in a system of variables, if in a sum term there exist all the variables, then we call it a max term. So we can write max term is a sum term where all variables exist. So for example, if we have a system of two variables a b, then a b prime is not a max term. A is also not a max term, but a plus b is a max term. A prime plus b is a max term. Now, so how many max terms there are for a system of two variables case? A b, two variables. Now it can be a plus b, it can be a plus b prime, a prime plus b, a prime plus b prime. So this m0 is the capital M now, the uppercase M, m1, m2, m3. So similarly, see if we have three variables, A, B, C, then so we'll have 8 max terms. A plus B plus C, A plus B plus C prime, A plus B prime plus C, A plus B prime plus C prime, then A prime plus B plus C, A prime plus B plus C prime, A prime plus B prime plus C, and finally A prime plus B prime plus C prime. The first one is uppercase M0, M1, M2, M3, 4, M5, M6 and M7. Now that any expression can also be expressed by using max terms only. So as you saw that any expression can be expressed by using min terms only. Similarly, any expression can also be expressed by using min terms only, max terms only, min terms only, or max terms only. Let's see this with an example. So we have a function, the same function that we saw in the previous case, in the case of min terms, and the function is of three variables, and it's a plus b c. So we want to express this expression a plus b c in terms of max term. So there are two procedures again. So let's work with the first procedure. First way, a plus B, C, L. So now we want to apply the distributive law, A plus B times A plus C, distributive principle. Now in A plus B, here C is missing, so what we can do, A plus B plus C times C prime. Is it okay? So we know that C times C prime equals 0, and adding 0 with A plus B will make it unchanged. So now here in A plus C, B is missing, so now we want to add B. B times B prime plus C. Now we again want to apply the distributive principle, and after that it will be A plus B plus C times A plus B plus C prime. Then A plus B plus C, A plus B prime plus C prime, B prime plus C, not C prime. So you got A plus B plus C twice. So now we know that A times A equals A. So A plus B plus C times A plus B plus C is actually A plus B plus C. Then we got that A plus B plus C prime, and then A plus B prime plus C. Now we need space. So what is the first max term? A plus B plus C. This is the max term, M0, if we can remember, plus A plus B plus C prime is M1 plus A plus B prime plus C, that's 2. We can write it the product of in case of min terms it was sum of, now it is product of the uppercase, then 0, 1, 2. Okay, so it's now expressed. The equation is now expressed by using max terms only. Now we want to study the second way by using a truth table. We know that the function was A plus BC. Now we want to find the truth table, A, B, C, and there should be 8 combinations. And that's the function A plus BC, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 1. Now we got 0 there, 0 there, 0 there, 1, 1, 1, 1, 1. So now in case of min terms, we picked up the ones only. In case of max term, we should pick up the zeros only. So how many zeros we have in this truth table in the output? 3 zeros, okay, 3 zeros. So now the first 0, the row number 0, row number 1, then row number 2. So 3 0 we have. So we have 0, 1, 2. This is the function. This is the function. So the function f of A, B, C equals that. So now the function is expressed by using the max terms 0, 1, and 2. We now study Karnaugh map. Or simply K-map. This K-map is a tool which is used to simplify Boolean functions or Boolean expression. Up to 4 variables. We can also do it for more than 4 variables, but it gets more complex. So if we have an equation of 2 variables, 3 variables, or 4 variables, it's better to use the K-map for simplification, because K-map is easier and it produces less error than using the Boolean identities. So in case of 2 variables, what will be the structure of the K-map for 2 variables? Let's consider the 2 variables A and B. Okay, so now for 2 variables, how many minterms we have? So we have 4 minterms for 2 variables, and we need 4 squares. Okay, so in one side we have A, and the another side we have B. So A can be 0 or 1, B also can be 0 or 1. So total combinations we have 4, 0, 0, 0, 1, 1, 0, 1, 1. And total minterms we also have 4. So now if the minterm is A prime, B prime, see here for A prime means when A is 0 and B is 0, it's A prime, B prime, the minterm is M0. Then A prime, B, the minterm is 1. Then A, B prime, minterm is 2. A, B, M3. So that's the K-map for 2 variables. And now you want to see the K-map for 3 variables and also for 4 variables. Then we'll see how to simplify the functions by using the K-maps. So let's see it for 3 variables. So 3 variables K-map. Three variables A, B, C. So we know that, so we should have 8 minterms now. So there you go. So in one side we have A, can be 0, 1, and another side we have B, C. So now 0, 0, 0, 1, 1, 0, 1, 1. So it's important to know that. So 0, 0, 0, 1, and then after 0, 1, we put 1, 1, not 1, 0. So it's 0, 0, 0, 0, 0, 1, then 1, 0, then 1, 1, because it's making a wrap. So because this side, and that side, these two are connected. We assume that these two are connected. So now the first minterm, M0, M1, and the M2 not here, it's M2 there, M3. So M0, 1, 2, 3, M4, 5, 6, not here, definitely not there, definitely not here. 5, 6, and 7. So that's a 3 variable K-map. Now we want to write the 4 variable K-map. Four variables K-map. So now for 4 variables, how many minterms we have? Total 16 minterms. Let's consider the variables A, B, C, and D. So we have 16 minterms. So we should have it this way. So now we have 16 boxes here for 16 minterms. In one side we have AB, and other side we have CD. So it's 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1. So the first minterm 0 1, then 2 3 4 5 6 7 8 9 10 11 12 13 14 15 is 16 minterms. Okay, so it's the we now got the K-map for 2 variables, 3 variables, and 4 variables. Now we want to know how to simplify the functions by using the K-maps. Let's consider a small function, a small example. Actually, first we need to find the K-map, then we simplify. Okay, so find the Boolean function for the simplified Boolean function for the truth table. Okay, so given the truth table, find the Boolean function. So one is given the truth table, find the Boolean function. So what is the truth table? A, B, 2 variables only, and the function is f. It's 0 0 0 1 1 0 1 1. It's 1 1 0 1. Okay, so now we know how to find a truth table from a function. Now we need to find the function from the truth table. So, and before doing that, so we need to find the K-map of 2 variables a, b. So 0 1 0 1, and so for each of the minterms we need to find out which minterms there are and which are not. So we know that ones indicate the minterms. So minterms 0 1 2 3. So 0 1 3 0 1 3, this 3 minterms exist for this function. So 0 1, you know this 0 1 2 3. For 2 is 0 1 1 0 1 1 1 0 1. Okay, so 1 1 0 1. So we got the truth table now. So we got the K-map now. Now we need to find the function. So there is a principle in order to find the function. So find maximum number of ons in the K-map in the K-map which are symmetric and consecutive. So, and how do you find that maximum number? Okay, these two ones are symmetric and also consecutive. Consecutive means one after one. Okay, so these two ones are adjacent. Now the function would be, so what is common for these two one? For this in the if we consider a is 0 for both this one and that one. For both of the ones, a is 0. But for the first one, b is 0. For the second one, b is 1. So b doesn't work in this case. In this case, a only works. A is 0. So now it's a prime because it's 0. Now, so we still have another one there, and we need to consider again the maximum number of ones which are consecutive and symmetric. So for these two ones, a is 0 for the first one and a is 1 for the second one. So a doesn't work. For b is 1 for both of the ones, so b. So now a prime plus b. So this is the function for the truth table. That's how we find the simplified function or the function so for a K-map. Let's see more examples. Well, so the example we have now is a function of ABC, and is in terms of the mean terms 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So that's the function. We know that 0, 1, 2, 3, 4, 5. So we know that any function can be represented by using mean terms. This function is represented by 6 mean terms. So now we want to find the simplified function. So since it's a 3 variable, and we need to find the 3 variable KMF for this particular function. We know that the structure of a 3 variable KMF is kind of that, and in this side we have A, and that side we have BC. 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. So now which mean terms we have? 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. And for 2 more mean terms, these are 0. So 0 means so when it is 0, we usually don't put it. If something is blank, then it means that it's 0. Okay, so now we need to find the maximum number of ones which are consecutive and symmetric. And how about this 4? This 4 ones. These 4 ones. These are consecutive to each other. These are also symmetric. Now, so what can we do? So what is common in these 4 ones? For the first two ones, A is 0. For the second 2 ones, A is 1. So A is not common. So how about for B? So B is 0 for each of the ones. B is 0. That's 0. That's 0. Okay, so then B, we got B. How about C? C is 0 for the first 2, and C is 1. So C doesn't work in this case. So we got only B. And now still we have these 2 ones. These 2 ones, and we need to find the maximum number of ones which are symmetric and consecutive again. So we can find this maximum number of ones, these 4 ones. And for these 4 ones, we see that A is common, A0, so A prime. B plus A prime. This is a function. This is the simplified function. Okay, that's easy to make. And this also can be made okay, so by using the mean terms. So what can we do? For 0 mean terms, A prime, B prime, C prime plus A prime, B prime plus C. So we can put here 5 mean terms. Then we can simplify this expression by using the identities. Then we'll get this simplified by. In this case, the KMF simplification is easier, simpler. It will also produce less error. So when we compute. Okay, so let's see more examples. The next example that we have, the function ABC, and this is again in terms of the mean terms. And the mean terms that we have now 0, 2, 4, 5, 6. Well, so it's a 3 variable KMF. It's easy to draw. Now for 0, yes. For 1, 0. For 2, yes. 3, no. For 4, yes. For 5, yes. For 6, yes. For 7, no. Okay, so we got 5 ones in this KMF. We want to find the maximum number of ones which are consecutive and symmetric. So the first way is, okay, so to see that this 2 ones and those 2 ones, they are consecutive because I talked that this side and that side. These are actually connected. It's a map. So we cannot see a three-dimensional object in a two-dimensional space. So it's a three-dimensional object, but we try to visualize it in a two-dimensional space. So we have to consider that these two sides are connected. So when they are connected, these four ones are consecutive. They are also symmetric. So now we need to find, so what is the common in these four ones? Okay, A is not common, B is also not common, C is common. So for C, for all of this one, the value of C is 0. So since this is 0, so we got C prime. Well, so still we have 1 here, 1, and we need to consider more the maximum number of ones which are consecutive and symmetric. So can we consider these two ones? I think we can do. And for both of these ones, A is 1, so A. B is 0, so B prime. C is 0 and 1, so C doesn't work. So that's the simplified function. It's easy. Finding the simplified function for a given function by using K-map is easy. We want to see more examples. The next example that we have, that's again 3 variables, and this 1, 3, 4, 5, 6 minterms 1, 3, 4, 5, 6. So now again a 3 variable K-map, A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So we have 0, 1, 0, 0, 1, 2, 3, 4, 5, 6. Now, in order to find the simplified function, we need to find the maximum number of ones which are consecutive and symmetric. So do we have 4 ones which are consecutive and symmetric? I don't think so. So we don't have 4 ones. Do we have 2? I think yes. So let's consider these two. Then for these two ones, A is 1, so A. B is not B is 0, so B prime, and C is not the same. C is not common. Okay, and that's it. For these two, A is 0, so A prime, and C is 1. C. So now for this one and that one, A is 1, so A. B is not common, C prime. So this 3 terms we get, and the function is that, and this function is a simplified function for the given function. So let's see more examples. So the function now we have is in terms of 4 variables, A, B, C, D. And it's not in terms of minterm. It's a regular function, A prime, C prime, D prime, plus A prime, D, plus B prime, C, plus CD, plus A, B prime, D prime. So now the first thing is so we need to find the K-map. So if we can find the K-map, then we can find the simplified function. It's not in terms of minterms. It's just a regular equation. Okay, let's draw the KMF first. Let's say 4 variable KMF, and in one side we have AB, another side we have CD. 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1. Okay, the first time we have A prime, C prime, D. It means that A is 0, C is 0, D is 0. So we need to find the boxes in the K map where A is 0. So where A is 0? So A is 0 here, A is 0 here, and the C is also 0. So where do we have C 0? So C is 0 here. So only this. Then D is also 0. Okay, so then only those two. This two is 1 for the first term. For the second term we have A prime D. So A is 0. So where is A 0? So in this 8 boxes, so A is 0 and D is 1. So D is 1 here. That's it. So now we have B prime C. So similarly B prime. So where is B 0? So B is 0 in this box, and also in the boxes B 0 and C 1. So C1, search C1, C1, yes C1, yes C1, yes C1. Now we have CD. C is 1, D is also 1. So C is 1, D 1. We got that. Now A, B prime, D prime. So A is 1. These 8 boxes. A is 1, B prime, B 0, D 0. So B 0. So in this 4 boxes, and D is also 0. Yes, we have got 1 here. We got 1 there. Also, we got the KMF now. Now we want to find the function, and in order to doing so, we want to find the maximum number of ones which are symmetric and consecutive. Okay, let's consider these first ones. These 4 ones which are consecutive and symmetric, and for these 4 the common is A prime, and on the other side C prime. So it's A prime, C prime. So now, so how about these 4 ones? The common is CD, and still we need to consider the remaining 3 ones. 1, 2, 3. These 3 ones. So we can see this one, that one, that one, and that one. These 4 ones are consecutive and symmetric, and what is common in them? A is not common. So B is 0. So B is common. C is also not common, but D is 0. So B prime, D prime, and we add pluses here. So F, the function, is the simplified function. Is the simplified function for this given function. Now we study the very last topic of this section, and this topic is incompletely specified functions. So incompletely specified function. Functions. So when the functions are incomplete, then we need to understand a term, and this term is called do not care. Do not care term. Do not care term. So if you can recall that, so in some previous classes we talked about an example, like I asked the bookstore if the textbook of this class is available or not. So they have 6 options, and okay, the book is available, book is not available, we don't sell the box, we don't sell the box, or the book will be available in the next week. There's 4 options. But for whatever for any reason, if 1 or 2 or 3, if any of the options are not needed, then those options we call that these are incomplete, and we call them don't care. So in case of don't care, it can be 0 or 1. So we can consider it as a 0 or as a 1. Let's see this for an example. So we have a truth table of 2 variables only, and the function we need to find. Zero, 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 1, 1, 0, 1, 1. So the function that we have 0, don't care, 1, no, not 1, 0, 1. Okay, so now, so what we have here is for the first row is 0, for the second row is don't care. So we always don't care by using this cross symbol. For the third row is 0, for the fourth row is 1. So what is the first row is 0, the third row is 0, the fourth row is 1, but the second row, it can be 0 or it can be 1. We don't care about that. So now we need to find the truth table. So in order to find the function, so the truth table for this function is okay, it's a 2 variable, the K-map, is a 2 variable K-map, and for the first one is 0, then don't care, then 0, then 1. Okay, so now this don't care, we can consider it as a 0 or as a 1. So what about the way if it gives the simplified function? We want to find the function, and there is 1, and we need to consider, we only think about this one. Okay, now try to find the maximum number of 1s which are consecutive and symmetric. There is only 1 in this case. Now if we are considering the don't care as 1, then we get 2 1s. This is the maximum number, but we can also consider this 1 individually, but this will not give us the simplified function. In order to find the simplified function, we need to find the maximum number of 1s which are consecutive and symmetric. So now in this case, if we consider the don't care as 1, then we have 2 1s, and these 1s are consecutive and symmetric. So now the function is, and in these 2 1s, a is not common, b is common, so b. The simplified function is b, f equals b. Now the last example of this class. Well, so the example that we have, so we are given a function of 4 variables, a, b, c, d. One, 3, 7, 11, 15, and also we have a function is the don't care function. Zero to 5. Okay, so now we need to simplify the function by considering the don't care. So it's a 4 variable K-map. So in one side we have AB, another side we have CD. 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0 0 1 1. Okay, so now for the minterms we have 1 3 7, 0 1 2 3 4 5 6 7, then 11 and 15, 8 9 10 11 12 13 14 15. Well, so these 5 mean terms we have, and for all of these mean terms we put 1. And for the don't cares, we have 3 don't cares, 0 2 and 5. So 0 is a don't care, 2 is a don't care, so 0 1 2 is a don't care, and 5 0 1 2 3 4 5 is a don't care, 0 1 2 3 4 5 is a don't care. Okay, so now we got the K-map, and we need to consider each of the ones. Each of the ones must be covered in order to find the function, the correct function. So now let's try to find the maximum number of ones which are consecutive and symmetric. Now in this case we can consider this maximum number of ones. These 4 ones, these are consecutive and symmetric. So, and these 4 ones, A is not common, B is not common, C and D are common. So C D. Now still we need to consider that letter 1. Okay, so now we need to find the maximum number of ones which are consecutive and symmetric. So now for this one, the maximum number will be that. So in this case, 2 don't cares we have considered as 1, and by considering them as a 1, we can find the maximum number of ones which are consecutive and symmetric. And in this block, A, B is common, and for both A and B is 0 and 0. So it's A prime, B prime. So CD plus A prime, B prime is the simplified function for this given function. Thank you so much.